Hello friends, welcome back to the channel Learn with Art. Now in this video we are going to implement the queue using linked list in C programming. So while implementing queue using linked list, we will implement queue by using singly linked list. So the node structure required for a node for queue is same as the node structure of the singly linked list. So I have taken here struct node which contains two variables. One is data and other is pointer field. Okay, in this data part we are going to store the integer element. That's why its type I had taken here integer, and this will store the address of next node in the singly linked list. So its type will be struct node only. So this is the required node structure. And again, for accessing elements in the queue, we have a need of two pointers. One is representing front and other is representing null. Okay, so I have initialized here both pointers to null because currently we don't have any front or rear element present in the linked list. That's why I have initialized it to null. Okay, now we will see what will be the main function. Here I have taken enqueue function for inserting element in the queue and dequeue function for removal of an element from the queue. Also, I'm going to explain you the display function for the display of queue using linked list, but here I haven't called for display function. If you want, then you can call it here. Okay, so while enqueuing element in the linked list, we will need an element to enter as a parameter for the enqueue function, but we doesn't need any parameter for dequeue function because while dequeuing element, the element present at the front end will get deleted automatically. Okay, so we don't need to mention which element we want to delete. Okay, so here total 3 calls are there for enqueue function and 2 calls for dequeue function. So here we are completing the main function. Now let's start with the enqueue function. Okay, so void enqueue, it takes parameters as I have discussed already in the main. So in main it takes one parameter. So first we will see the first statement in the main function. So enqueue 11, this will call the enqueue function, and here the value of item will be 11 as 11 is passed as a parameter. Okay, so value of item is 11 now. Now for creation of a linked list, we need one parameter, one pointer. So I have taken here struct node star. So I have one pointer named as temporary. Now we will allocate memory to this pointer so that we will have one node created in the memory using malloc. For that purpose I have used statement temp is equal to struct node star malloc size of struct node. Okay, so this will allocate memory to temp pointer. So this is the blank node we have created in the memory. Now we have to put the values in this node. Okay, so now the value of item will get copied in the data part of this node because we want to have element 11 in the queue. Okay, so first I'll copy the value of item in the temp tends to data field. So this will contain 11. Okay, now we will check whether the inserting element is first element in the queue or not, because while implementing queue using linked list, first we have to check whether the inserting element is first element or not. Same is the case happened with the implementation of queue using array. If we are inserting first element in the queue, then we have to update both front as well as rear, and if you are inserting second onwards element into the queue, then at that time only the rear end will get updated, or the value of rear is going to be updated. The value of front will remain as it is. Okay, so that's why first condition is if front is equal to null. So we have initialized front to null globally only. Okay, struct node star front and rear is equal to null. Okay, so this condition satisfies here. We want to insert first element, so this condition satisfies because this inserting new temporary node will be the first node in the linked list. Okay, so temporary node will be assigned to front node as well as temporary node will be assigned to rear node. Okay, so front is equal to temp and rear is equal to temp. Now we have assigned the value of front to temp as well as rear to temp. Okay, now this is the single node present in the current queue. Okay, so we will mark the front tends to next is equal to null as well as rear tends to next is equal to null. Means this is a single node representing both front as well as rear. Okay, so I have initialized front tends to next is equal to null and rear tends to next is equal to null. Means their next is pointing to null and front and rear is this single node, that is temporary node. Okay, so this condition satisfies, so it won't go to the else part. So here the enqueue function will get completed for execution, so it will return back to the main function. In main function we have next call for enqueue 22, so it will again update the value of item as 22, so it will call enqueue for value of item 22. Okay, now again the new temporary node will be created. Okay, so in memory we have created one more temporary node and we will allocate memory to this temporary node by using malloc. Okay, now again I want to make copy of item to temp tends to data, so now 22 will get copied in this new temp tends to data. Okay, so 22 will get assigned over here. Okay, now here we will check the condition, that is if front is equal to null. So this condition will not be satisfied because now the value of front as well as rear is this 11 node. Okay, so it will check for the next condition, that is else part, so it will go in the else part. And now here we have to update just the value of rear. Here we are inserting element in the queue, that's why front will not going to be updated. Front will update only while dequeuing the element. Okay, so here rear will get updated as rear tends to next is equal to temp. Okay, so now my value of rear is this 11 node. Now we will assign the next pointer of this rear to temporary node. Okay, so the structure will be like this is my front as well as rear node. Okay, now its next field will point to this new temporary node. Okay, so rear tends to next is equal to temp node, so rear tends to next will point to this temporary node. Okay, now we have to update this temporary node as rear node because this will be the new rear. Okay, so now I'll assign this temporary node to the rear node, so rear will get updated but front will remain same, that is the first node. Okay, because first inserting element will be the first element to move out from the queue. Okay, so front will remain the same node and rear will get updated to the next node. Okay, now this rear node's next field does not point to any node because we don't have any next node inserted yet, that's why it will point to null. That's why rear tends to next is equal to null now. Okay, so here else part is completed as well as the function enqueue is also completed. Okay, now it will move back to the main function and in main the next call is for Enqueue 33. So it will again call for the Enqueue function with the value of item 33. Now again new temporary node in the memory will get created. Okay, now we will assign memory using malloc. Now we will copy the value of item, that is 33, in the temp tends to data. So here 33 will get assigned to temp tends to data. So now for front is not equal to null because we have front as 11th node. Okay, so now it will go in the else part. Okay, now this is my rear node. So this rear, we have to connect this rear with the new node. Okay, so this rear will point to the temporary node. So this will point to this. So it will look like, now this is pointing to temporary node. Now we have to update again the rear because this will be the new rear. So temp will be assigned as rear, and now this will be the rear node, and we don't have any next node present right now in the queue. That's why its next will point to null. So rear tends to next is equal to null. Here the else part of Enqueue operation, Enqueue function is completed, as well as Enqueue function is also completed over here. Okay, so it will return back to the main function. Okay, so here we have done with all Enqueue operation calls. Okay, now next call is for Dequeue operation, that will be continued in the upcoming video for Dequeue function. So now this is the current content of the queue as a linked list. It contains 3 nodes. Front node is 11 because we have inserted first element as 11, and the last element we have inserted is 33, that is the rear end. Okay, hope so you have understood how we have enqueued element in the queue using single linked list. If you have any queries, then please do comment, and never forget to like, share and subscribe to my channel. Thank you very much.